Hello everyone, this is Steven, and I've decided to give a Hello World tutorial that is a little bit past what you're used to, so this will be for beginners as well as people that have been coding for a while. There's a lot of things going on in the latest code world, and some of these things are senior programmers that don't understand how linkers work, senior programmers that don't understand how memory works. So this is a little live video, just a draft even, to get started and see about getting some more depth to understanding what's going under the hood in Hello World. So in front of me, I have Visual Studio, but I'd like to start a little before this. So a lot of people have been getting imposter syndrome where they feel like they don't belong in their job, they don't know what's going on, and I came here to address this. So unfortunately, I don't have any graphs with me or anything, but this video you may add graphs, or I may edit and add graphs to more pre-planned videos in the future. But right now, let's just start with what computers are and how they work, and I'll keep it really simple and really short, but also in depth enough to where you don't feel like you don't understand something, at least up until the point on how it's actually implemented, because then you'll have to go and look it up. So the start of computers, you could say, I would run to capacitors, and the reason why capacitors are where I start is because they have a timing on how they fill up. And you could say if a capacitor of a certain charge fills up at 5 volts and it has this specific charge, you know that it's always going to discharge at, like, say 3 seconds or whatever the time is. So a capacitor is what gives you the clock, and this clock is the electricity that runs straight into the CPU. And a lot of questions people have are like, how do CPUs become translators for meaningful things? Well, think of a bunch of like pipes and gates. So the transistors and the CPU is a bunch of pipes and gates, and we tell it when to turn on, when to turn off. So right now, just think about like plumbing, and I'm so sorry I don't have a graphic or anything to show, but feel free to add any of this video. You can use however you like. So let's say you put some water into a pipe and it turns on a blue light, and then you make another pipe and it turns on a green light. You kind of see where I'm going with this. A monitor is a bunch of these, so obviously it's going to have a lot more than just 3 pipes of red, green, and blue. But if you dump water in a bucket and jump it into the pipes at different times, you'll get the lights to turn on also at different times. And if you arrange the lights in a certain order, well, suddenly there's some meaning. If you have a 10 by 10 grid, well, then you'll have 3 by 10 by 10 pipes, and that's 300 pipes. And that's kind of what computers are doing, is they're letting you dump all these buckets of water at specific times, or voltage, electricity. So I guess electrons. But anyway, when they get dumped really fast, you get them to turn on at a certain point. Suddenly you have the letter A, B, and C on your screen, but it boils down to the meaning is what you add to it. So I think this should have gotten rid of the mystery for many of you. Obviously the implementation is a little lacking, and there's a lot of complex things under the hood, but that gives us a start. And what happens there is it kind of attaches itself to other things that have these meanings, and we call them hard drives and peripherals. So we have a monitor, and we have RAM, where programs, which are these pre-built pipes, you could say, or pre-built sets of buckets to fall down, well, they get shoved into RAM, where it just happens really fast. So I'm going to add now that we kind of have a start, let's add a file here. And it doesn't matter what you name it, but what matters is it's called the main entry point. So usually we name it main.cpp for C++, Mazin. And this file, so computers have a starting point, and this is the main function. If you're a new programmer, then I should explain what this does to you. Int means integer, it's the return type. A function returns, and I'll explain how a function gets called in a sec, by giving a parameter back at the end, or when you say end. And this, for now, let's just say when I return 0, it means everything's good. If I return something other than 0, it usually means something's bad. That's That's just standard protocol in Unix. It doesn't actually do anything to the program. So now that we have a starting point, let's run, but I'm getting a little ahead of myself. Don't worry, so just make sure this runs. Shows up on screen. I'm checking my screen in a second. There it is. Obviously it doesn't do anything, so Visual Studio says, let's get out of here. Okay, so a program is a bunch of words and letters and symbols, and if you do Python then it's spaces, but the spaces kind of represent these symbols. And there's a process called parsing and 3 other processes, I believe: tokenizing, linking, and assembling. So what happens is this gets parsed, and I believe that's the text editing or text reading spot. So if I miss something, like I missed my parentheses here, it can't parse. Tokenizing is to make sure that all of these things can become kind of like a graph, or it's a tree, like a little flow chart. So 1 goes to 2 things, and obviously there's no 3 pipe symbol on the keyboard, but you get the idea. And that, it just makes sure it's following the rules for the next part, which is assembling. And assembly is to take those tokens, which is turning it into machine language. Now, machine language is weird, and it's called, they call it targets, or what are you assembling to? And these assemblies, when they get assembled, if this code runs through the compiler, it becomes whatever I named it, so main.a, A for assembly, or main.o, O for object. And the O, actually it's just object. Assemblies are different. I'll go over that in a second. So that means that the machine can read it, or rather a machine can read it. So C++ goes to machine code, and that is one assembly. If it's Intel is one, AMD is another, ARM is another, and that's why you have targets. Targets go to different machines. Now, the next part is linking. So now we can finally go back to the beginning of Hello World, or what's usually the beginning. Now, there's parts of computers that are already, these libraries are already built, and they are able to do things pre-built that you shouldn't have to code yourself, like printing to the screen. And if you print to the screen, you only have to code their little instruction, and in C++ it's cout for console output, or standard output, or standard count. Hello. So what I'm trying to get at is that this is pre-built for you, and it's pre-built in this include file, which has been like a pre-made assembly. So there's a bunch of programs made for you in what's called the standard libraries. And I'm not referring to the stdlib or the C++ standard library. I just mean what comes with your language. So anything that has little caret brackets around it is a standard assembly. And those mean that someone already programmed something under the hood for you that either does a common algorithm, which is just something you do in programming, that's really common, like sorting something, or it connects to the machine. So this I/O stream has input-output streams for reading from the keyboard and reading out to the monitor and reading out to maybe the printer, anything that's standard, probably not the printer, but it was coded for you, and it translates your standard console output into machine language for the machine you're on. It does another thing. It's called the runtime. And it's the glue, instead of just between the machine and your language, that kind of links to your operating system. So a runtime is a lot like the linker, except for your operating system. That's a terrible description, but it's for an overview, I don't think it's too bad. It gives you an idea of where to begin researching. Or at least when you hear the word runtime, you're not going to be confused as to what's this magical thing that my code runs on. Well, it's the glue to get this standard console output to not just go to some random machine console, but to go to Windows's command console. So that should be a bit clearer. Okay, so now we have a few more basics to get over, because I know that standard : is confusing, and I still haven't gone over this. So int main void, programs operate on functions. Every program is a function called main. DLLs, there are functions your programs can link to that don't have any main function, like how it prints to the graphics. So int main void, there's a bunch of ways to write this. It just depends on what you are doing. So this void is where the parameters and what's coming in are. And if you're running this program, you can pass things into it. So if you started it from the command line, you could just say, like, this is main, and then I could throw in a string to it. Say it's your name. And then one of the parameters in it, it would say, oh, there's a parameter, so then I should read it. So usually it has two parameters. The function has two parameters. You can throw as many as you want into the function. The function itself reads the amount of arguments, argument count, and then I believe a string, which is a bunch of letters. And it's rather an array of strings, so it's a bunch of sets of these. And there's a bunch of ways to write it. But basically, that is what you wrote. And if I wrote something like just a program you're already familiar with, or the old programs, so like copy. When you're copying a folder or a file, the file.txt is the argument, and then you could say the path to the next folder, and its next name is the second argument. And what you do, which is a little past the context for hello world, but you'd read it from this args thing, and there's 0 and 1, or 1 and 2. You start at 0 for these things, but I'll just say 1 and 2 because we're not there yet. So argument 1 would be, actually sometimes it's the command you put in, so you have to be aware of that. And then argument 2 would be the parameter you put in, which is file 1. So args 1. So you could say that is file 1. And that, what I'm writing right now, is for demonstration purposes. That's not code. Anyway, this just takes the arguments you put in, and you can read it, and you can tell Windows to do that in programs. This is the return type. So if you have a function that takes in two numbers and adds them, and then it just returns what that number is. Now let's go into the next line to make this more in depth. So to make this stop for just a little bit, we're going to make it take in an integer. First I have to create the integer before using it, so int I. Use better naming with things in production, but I'm just using I because it's obvious for our purposes that it's an integer. So what int I does is it creates a spot in memory and it allocates it on what's called the stack. And this used to be 16 bits. Yeah, a long time ago. It was 32 bits. It's whatever the bus size of your your motherboard, your motherboard. It's the bus size of your motherboard, which is now 64 bits usually, so this could be 64 bits. But 5 or 10 years ago, this was usually 32 bits, and 10 years before that, it was even smaller. So, and this used to be garbage memory, which means it would just allocate 16 bits, or 2 bytes rather, or 32 bits, which is 4 bytes, and it would just use whatever's there. I believe newer compilers automatically set them to 0. But if you just randomly printed it to the screen in the past, and this might still be true of pointers, it'll print whatever was in that memory. It doesn't matter. Which brings me to another point. All this is 32 bits, or 4 bytes of memory that the computer doesn't care too much what it is, except for you told it to tell it to respond as if it's an integer. So the fact that this is just 4 bytes of memory is almost all you really need to worry about if you want to do some tricks later with bits, and if you're typecasting or anything of that nature. But those are for later videos because that's more of an advanced topic. Alright, so we allocated 32-bit integer on the stack. Stack is faster than heap. Heap allocation is really slow. And remember, a pointer is something that's on the stack usually, and it allocates memory on the heap that it points to. If you're a new programmer, don't worry about what I just said. Let's go to the next part. Standard cin. So this standard part is a namespace, and this is really just a naming convention. Like I said before, computers are very slapstick. They don't care what's what and what's where. What we do as programmers is we add these contracts. These contracts give us rules and control, and unless we're programming in straight assembly, these rules and control help us to avoid problems, to avoid shooting ourselves in the foot. So what standard is one of these, you could say one of these standard libraries I mentioned earlier. A namespace is not a parameter, usually a space between two brackets, you could say. Just a scope. It's a scope of where you want to put a prefix before things so that they don't collide with other names. So say someone else is also making console input, like your company. So if you have enterprise.console input, you don't want it to confuse itself with a standard console input. So they created a namespace. And there's two ways of using them. One is directly like this, where you say standard namespace, their console input, which is within this IO stream, I believe. Or you can just tell it to globally, within your file, use the namespace. And what this does is it automatically appends standard, or whatever namespace you decide. So, honestly, that's just the implementation of a contract. There's no magic on the code for this. It just tells it where to point. Since this is global, people don't like to use it because it kind of spams it on everything, and it slows things down, at least as far as the general feeling goes. So since this says console input I, it's expecting an integer. So let's run this again. You'll notice it'll probably be blank because it's expecting an integer. So I'll put 8, hit enter, and because it doesn't do anything, it returns 0, which means everything's good. So this return 0 is probably the last part to explain. We're not in functions yet, but I'll give it a whirl. So the way the stack works, besides just having variables on it, is, oh, I just got a... hi, Gabriel. All right. Yeah, I wasn't expecting an audience, so yeah, I'm actually intending on editing this later, so hopefully all the ums and ahs and a more professional video will come out. But first, let's finish this. So the stack is kind of like a place in memory where you put instructions on. So the int main function is also very similar to a variable, but bigger. It's instructions. The little pipes read it as what to do instead of what to hold on to. So this function will end, and it goes back to, you could say it pops back off of its stack and goes back to the operating system because it's the main function. In the future, you learn about buffer overflows, maybe not from me, but at least where they can happen. And that would be the function returning, but maybe one of these strings is too long or too short. And it's supposed to return to a certain spot, but you can kind of point it at the wrong spot, and that's what a buffer overflow would do. In a normal sense, sorry, I got distracted. The function would just it puts memory and variables in a spot, and then it says, I'm going to use them with these instructions. And you can make a function kind of dive into itself to use the same instructional memory. And this would actually loop forever because it would just constantly call itself, assuming that it's not expecting arguments. There we go. And you could throw another variable in there. If it was just a normal function, you could just throw an integer in there. Just main, you can't do that because it's expecting to be ran from initial time. But basically it would just constantly go on this memory called the stack, and you'd call it forever and hopefully have a condition to make it pop back off. But what you should think about is that the processor is more like a stream of pipes that continuously gets ran into, and it just addresses memory, and then continues. It literally runs in a circle. And I got way ahead of myself, or rather I should have said that at the beginning. So by running in a circle, what I mean is the operating system itself is actually a program that is running in a circle. It's called the kernel. When you turn on your computer, the kernel has these instructions, and these instructions, they kind of tell it, it's a predefined protocol of how to interact, much like the meaning I talked about at the beginning. The hard part of a computer is getting everything to interact in an ordinary, agreed upon way for everything to communicate. So your hard drive and your printer and your monitor. So what your kernel does is it runs around whatever is attached to it and tries to communicate using these protocols, which are basically just pre-set up pipes. And it just spins forever doing that. So hopefully that has demystified most of the computer.